Right. Hello. Let's see. Everything's working. Yeah. Okay. Cool. Good morning. So let's see. I had some reflections this weekend, and with all my reflections, they have a tendency to become something practical, to kind of prove a point. And Bonsify sounds weird, but it's coming from what's it called? The bonsai tree, because it's related to state and state trees and like having a minimalistic view on doing state management. And what I challenged myself with, because through these reflections, I was like, how the hell did we get to this position where, well, let me take you through. I'm not going to read the docs for you, but I'm going to kind of talk about it. So the result of it was to challenge myself to create a state management tool that has a single primitive called reactive here. And it has nothing else. Like your code will not have any new abstractions or any other special primitives. And even this primitive doesn't do anything to kind of the code. It does something to the underlying mechanism. So this object works just like a normal object. It just makes it reactive. That's the only thing it does. And these reflections were related to like over 10 years of experience, like dealing with state management, where I initially worked with AngularJS. And AngularJS, like reflecting on it 10 years later, learned me a couple of important lessons, which was to think about my application as a state tree, which the UI is derived from. So with AngularJS, when I built this coding concept, I was using AngularJS had something called scope. So you actually had kind of a single state tree under, you wouldn't call it that in the AngularJS days, but it was that. It was this single object called a scope that was exposed at different levels based on your controllers and stuff. And then you could use the root scope to make things available to any part of your application. And it wasn't really recommended to do that because of performance issues. But the idea of having like this single root object where you can discover and access all your state and functionality related to that state, that made me super productive. And another aspect of AngularJS is that it allowed me to interact with this scope with plain JavaScript. I treated this scope as a normal JavaScript object. I used normal JavaScript mutation, and it just worked, right? I was super productive. And then as we got into React, we got immutability, and that since JavaScript doesn't have immutability, it changes how you express changes. You can't use the normal JavaScript change API, if you want to call it that. You would have to like do this set state, and you have to think about changes differently because you couldn't just assign a new count. You would have to look at the current count and then increase it here, and then this is like a merge thing. Like you have to learn something very specific, and that's just the signature you have to learn. And then it's the underlying idea of immutability and value comparison to just build something. It's kind of insane that you have to understand all those concepts just to build an app. And then it got even worse when we got, like, the great thing about function components is that you can just have a function return some JSX, and you can use conditional or dynamic JavaScript to change how that component handles its JSX, like the actual UI. But when it comes to state management, at this point, you had an even more exotic primitive because it was running inside this reconciliation loop. So thinking about this function as being called again and again, returning different JSX that automatically updates the UI, that makes a lot of sense. But having this function called again and again, calling this hook, passing this object where the count is 0, like that's just mind-boggling. And that's not taking into account effects and all that stuff. No matter, a lot of solutions, and then it was a performance issue of React, where it was more like AngularJS was slow, but React was not fast either. And it put it into the hands of the developers to make it performant enough. And then there was a lot of solutions, like I've been part of some of those contributions, but they all come with all these abstractions and primitives that I think was inspired by a lot of the teachings from React about what is the correct way to do programming. And maybe it's theoretically correct. That's arguable, but it's as a state somewhere in the docs here, it's complete bullshit. Because even though immutability is like more correct, and you remove the bug where a mutation might change an object from under your feet, like it brings along with so much overhead, and especially mental overhead. There's a reason why JavaScript is popular. It's a very simple, intuitive programming model. Just having objects, you add some values and some methods to those objects, and you just change stuff. The thing that a state management tool needs to solve is to make that object reactive. That's the only thing it really needs to solve. Everything else you can solve just using the language. That's my argument. Anyways, and then I continue like, my reflections continue to be like, when you look at a piece of UI, the great thing about components is that it's given you a mental tool for translating what you see as a result on the screen to something that relates to code. So in this case, like when I'm looking at this, I'm thinking about what are components here, right? So adding this to do is probably a component. This list is a component. Maybe each to-do item is a component. The footer is a component. And I can like intuitively derive that from looking at the UI. And when I jump from the UI and into the code, it's very likely I'll find folders and files that somewhat is similar to my mental model. Anything else will be super weird, right? But when looking at this, you can also derive like a mental model of the state. So you would think about, okay, we need a filter. You need to be able to change the new to-do title. If you edit a to-do, you need to be able to edit the to-do title. You have the actual to-dos. You also have the current to-dos, which is derived from the to-dos and the filter. You can add a to-do, you can set the filter, you can toggle completed, blah, 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 blah. And the point is that with JavaScript, this is how you, well, that's yet to be proven, but I would argue this is how you create a mental model of the state of the application, right? And then the question becomes like, where does this, when I go into the code, how well does this mental model of the state translate into the actual code? And if some of the state is like a bunch of components, some of the state is within a component, some of the state of a component comes from some parent component, maybe there's context there, maybe there's a global state store concept, maybe there are multiple stores, like this mental model doesn't map well to that world because you can't find like directories or files that kind of reflects this mental model like components would do. But what if this is actually how the state definition of your application actually looked like? What if we take inspiration from mental models and express that mental model in the code? And I would argue, at least with my experience from AngularJS and reflecting on why I was so productive there, it was because I was working with my mental model. I was literally like working with my mental model. And again, maybe this is just me, but working on cerebral and overmind, like the thing that makes people feel productive in those tools is because of having this single state tree. And then I continue writing about like the bullshit of immutability and like reducers, like a new abstraction for state management, like use reducers. And there's so much overhead to it. And like the only thing it guarantees is that any change to state happens within the reducer. But what the fuck is that an actual practical problem? Like if you have a single state tree and you are allowed to change that state from wherever, like it doesn't matter that you change it from wherever. Like it just doesn't matter because you have these specific functions in the state tree to move the state forward. But if you want to bind an input to a specific field in your state tree to keep it in sync, like that's fine. Like why is that such a big problem? And then maybe someone changes some state from a component where you would ideally want it to be from a function in the state tree. Okay, then there's miscommunication in the team. We're not aligned on patterns. There was a bad code review. Like, yeah, why add all this overhead boilerplate stuff just to prevent people from doing that kind of thing, which is like it's such a theoretical problem. It's not a practical problem. And what this has led to is like even MobX, which is actually very similar fundamentally to what I'm doing here, only that it has a bunch of other primitives, is that it didn't come with actions. Like it was just an observable, right? But the reason it had to introduce the concept of actions was to protect the state changes to only happen within those actions. But then we got async functions, and now these actions weren't able anymore to handle that. Like you could protect until you awaited, but after the awaited, you couldn't protect anymore because you can only synchronously protect state changes in an action. And then to handle that, they introduced a new primitive called flow to kind of just mitigate that. And at the end of the day, all of this is fucking bullshit. Like, imagine that. Just this like idea of protecting the state that no one really cared about before until someone just theoretically presented the idea that this needs to be protected. It pisses me off. But again, like the point there is that all of these things has been introduced, has been well intended, right? It's just that just the cost of doing something theoretically correct can be very, very high and lead to us like reducing a lot of momentum and productivity and just joy of getting our ideas into code. Anyways, so then there are like many different things you want to do to be able to scale up your state management in an app, right? You can start out very simply with a counter, but then shortly you'll need to like dynamically initialize the state where you just use a function for that. You need to do nesting, which you just do naturally with object composition. When you derive state, you can just use a getter in your object. Like JavaScript has this functionality. And then there's arguments about computeds like being more efficient because they cache. But then again, how many derived states do you actually need to cache? Like you have to have a very expensive computation for that to make sense. And then if you have a expensive computation in a computed, do you really want to reevaluate that computed as the component extracts the new value during its render phase? So I argue that this is a bad construct. you should rather, if you have expensive computation, you should manually trigger that computation and update the value. Maybe if it's so expensive, you probably want to even run it in a worker and do it asynchronously. And then you might want to access parent state, and here's the pattern for that. Using a getter again. Persisting state is super simple because it's just an object with functions on it. When you stringify an object, these functions are omitted. And again, if you want to bring back that state, you can just parse the string you persisted and just spread it into the state. To do disposal, you can just add a function to do that disposal. And then I also argue that effects and reactions are bad constructs as well, because it creates indirection in your code. And if you're not familiar with like the practical aspects of indirection, this is a simple example where you have an increase of the count, and then you have an effect logging that count whenever it changes. And lukker du døra, Ragnar? Anyways, so the indirection happens here because these might not even be in the same file. Like you see them together here, but they might not even be in the same file. Oh, fucking kids. They might not even be in the same file. So when you look at the increase code, you see that the count increases, but you have no idea about this effect. When you look at this effect code, you have no idea where the state count changes. But if you put them together, you know exactly what happens when the count increases. And then again, you can argue like, yeah, but what if the count is changed from multiple places? What if the effect looks at different states and so on and so on? So you have like two different states and the same thing should happen regardless of which state is changed. Well, there are patterns for this in programming where you lift logic up. So instead of changing individual fields, you create a common function to change both of them, for example, where you include the additional logic related to making changes to them. So it's like primitives and abstractions has a cost. And I think we completely ignored that cost for very, very long. And we've gotten used to having all these primitives and abstractions. And it's stupid. Another thing that this does is that it removes observation. So typically when you have observation in React, you have to have these higher order components or some special logic that does observation. So when you use the counter here, like how does this app know that it's gonna render again? Well, in this project, there's a Babel and SWC plugin, which just makes every single function that you, that makes every single function that you define as a component in your code becomes an observer. So that means that it doesn't affect any like third-party things or anything, but the overhead of making a component an observer is like super, super tiny. And what happens is that it makes your rendering predictable. Like it will only render again if anything that it actually accesses from the state changes. And you won't have waterfall rendering because it uses memo. So you won't have this like unpredictable rendering where I had a nested component here that doesn't take any props, but it just reconciles again because this rendered. Like it's very predictable rendering. It's how your mental model is. The way Vue works. Vue does this. Vue has very predictable component rendering. Like it does what you think it should do. And with this plugin, it also does what it should do. And you don't have to think about it. It's just super performant out of the box. And the only thing you kind of think about is scoping components. Like if you have a big component that accesses a shit ton of state, that can, like in extreme cases, cause a performance issues. For example, if you have a component of a list and each item in that list accesses a bunch of state and that state changes all the time, like the whole list component would like render every time. But what you typically do with lists is that you create a component for each item in the list, and that by the fact of just doing that, that optimizes the components, because each component accesses less state. Like that's the only thing you have to think about. How much state is the component accessing? Not how does it pass props, how does the prop change and all of this stuff. Adding like memo and use memo and all of use callback and all of this stuff. It's silly. And then there's this concept of state machines. And there's one thing that's always bothered me with state machines. So the great things about them is that they present explicit states. So there is a literal string that explains what the state is. And then with that and TypeScript, you're able to narrow down what state is available in each explicit state, like what values. And then you can also exhaust that list, or sorry, exhaust those states. So you can use a switch statement or if statements to kind of exhaust what you're accessing. And traditionally, state machines uses like a dispatcher. So you can just tell it to do things, but it will check its internal state if it's in a state where it should execute that request. And that's the thing I have a problem with, because from a consumption point, there's no link between doing something and what state is valid to do that thing. So what's interesting about this is like it's super simple to implement a state machine just using JavaScript. So here we're creating a toggle machine. And this toggle machine has a foo state and a bar state. And the way we express that is creating two variables that is a function of moving into that state. So you can like give it, arguments. But it also defines the functions available in that state. So here you can toggle and you can transition back to bar. And here you can also toggle and you can transition into foo. And then we just return the initial state. And what's great about this is that when you actually consume this state machine and you look at the state, it will not only tell you what other values, what other state is available in that explicit state, but it will also tell you what functions are available for that state. So imagine like an authentication flow where you have unauthenticated, authenticating, and authenticated. You can only sign in when you're unauthenticated. You can't sign in or sign out if you're authenticating. And if you're authenticated, you can only sign out. And that would actually be reflected in the typing and in the functionality using this. And another thing that's interesting about this is that it creates a pattern of creating a scope around state. So even though we're returning just this, in this case, the foo object, like that's literally what we're returning here, we have encapsulated all this functionality with that state, which I find very, very interesting. Cool. So let's see. So I thought we could play with it a little bit. Let's see, I just have to make sure I'm making myself let's see. Okay, yeah, just have to be available. Let's see, so this is like a typical React application. And we have, let's see, we have the count here. And what we are going to do is import, well, I guess we can just remove this. And then we can say counter equals reactive count 0 increase this dot count. And I don't have to use this. I can use counter.count instead if I want to do that. And then we're going to use counter.increase. Let's see. And then we're going to use, yeah, so what's interesting about this, I didn't actually think about that. So you can say counter.increase, and then we're actually going to do this instead. And then counter.count. And this is pretty cool because I didn't do anything else than importing the only primitive that's in this library, Bonsify. I created my counter, I added it to a component, and it just works. And I'm not saying that, like, what's the value in that? And I think the value in that is there's a promise there of simplicity, and that it's in the hands of you and your programming skills in JavaScript to make this application work. It's not because you've learned and gotten a bunch of experience with this very specific tool. For example, Redux. Like with these special abstractions and these special primitives, it's just because we kind of just handing you the thing that you can't do on your own in JavaScript, doing this reactive behavior, which I really think is great. Cool. Yeah, you know, I think I'm gonna recommend this pattern of like pointing back to the variable instead of using this. It's just because you can do things, you can reference the function and it will work without like just doing this and stuff. Anyways, so what I thought we could try to do is like we can remove all of this stuff, and then let's just say hello, and then we don't need this stuff. And I wanted to just try to play around with while I'm waiting for some responses here. Yeah, great. Okay, let's see. So I thought we could look at it to do MVC and like try to just, I don't know, implement and play around with. I haven't played around with this. Like to me, again, like the reason I built this is to make a point and also inspire discussions and reflections on where we've gotten as an ecosystem in terms of state management. And then yeah, just play around with it and hopefully like spur some discussions. And like if it happens to make sense, maybe something will come out of it, but that's really not the goal. So with the to-dos app, like we need to know, let's actually type this. So we have new to-do title. Let's new to-do title, which is empty, and let's just call it app. And I'm not gonna actually, so I'm just gonna have an input, which is value app.new to-do title. And then on change, we're actually just gonna change it. As I said, we have this weird thing of like isolating changes, but it's perfectly fine that app new to do title target dot value is value. I can't remember that we are. Oh, did I forget the parentheses? Oh no. Oh, sorry. That we are changing it, and hopefully it actually works. Like I haven't tested any of this, so hey, hello. So that works. And then what we want to do is we want to be able to hit enter. So that will be on key down event, if event.key equals, is it enter? I can't remember. We want to call add to do, and that's not going to return anything. And then add to do, yeah, let's do this thing. We're going to say, well, of course we need some to-dos. So let's just do an array of them. Let's do type to do, which is title is string completed boolean. And then to-dos will be like this. And what we're going to do is we're going to say to-dos push, sorry, app to-dos push. Title will be app new to-do title, and then completed will be false. And then we say app new to-do title is empty. So let's say app.new to-do title, sorry, no, app.add to do. Let's see. Well, it emptied it. So let's start listing the to-dos. So this would be app.todos map to do into, let's get the index as well. Sorry. So that will be li. Let's just bring in the to do for now. Key would be index and the title. Oh, what did I do? Oh, interesting. Did I break something? Oh. Because I'm like arrays, they have like the thing about this, the reactive state is that it's like it's JSON, right? So you only manage like any of the what are they called? I guess they're called primitive values in JavaScript, and then objects and arrays, because that's what you can send to the server. You can persist it. Like it's a good JSON is a good state format. But you can still use sets and maps and everything as like internal things to the state, but exposed state is JSON. Anyways, so to handle arrays, like objects work like just set and get, but arrays are different, have different methods and stuff. So I have a feeling that there's something I'm missing in my implementation. So if I can figure out where the hell I can see the, where's the edit? Is this where you do the, how do I see the developer thing? Show developer, isn't that a thing? Show, yeah, show features for web developers. Show web inspector. Ooh. Oh, interesting. Target observers. Okay, so I definitely did a boo-boo. Target observers dot add. Okay, let's see. I think I need to fix this for us to move on. So I'm making an assumption here that when the observer subscribes to its targets, Oh, that's interesting. Why does it say target observers is undefined? Oh, fuck, it's not add, is it? It's set. No, it's add. Sorry, it's add. How did that happen? How did that? Because this is a set. All target observation. Why does it say that add? That's super weird. Because that is a set, and sets have add. Maybe I can actually look at this. Can I do this? So, okay, maybe that's fine. How do I continue execution here? That's also set. Let's see. Is this where it broke? I don't understand this. This looks very weird to me. Why isn't it showing me? Why aren't I getting any things here? Oh, this is sucky. Do I have to actually go in and change the... There it's a set. Now it's a set, it's a set, set. Oh, suddenly it's a function. Okay, let me check the code. Maybe we can look at it together. It's actually less than 200 lines of code, which is pretty cool. So we have target observers, and somehow this became a function. What did this look like again? I forgot. So we go through the targets. And then we go through each key it's observing on that target. Then I'm grabbing the target. Actually, I could grab that up here. And then I'm grabbing the observers. Which is a key. I'm not sure why I'm setting this again. I don't actually need to do that. Okay, I'm going to change a couple of things. I'm just going to do it from my laptop. Let's see. So we definitely don't need to, or maybe we can change it here. We can figure out the actual bug. No, wait, I can't do it from here. Yeah, whatever. Okay, so we are, let's look at the code again. So I moved grabbing all target observation up. Then I'm going through the keys. And then all target observations, key. So the thing that really happened here is, oh yeah, and I don't need to, yeah, it's interesting. I don't need to set it again. How did it become, you know what, I have to be able to look at this. And I don't have things running on this computer. Anyways, I'm gonna fix that. I'm not sure what it is. Oh, yeah. Okay. So what we're gonna do, we're just gonna theoretically, what the hell happened here? Oh, the whole thing. Why can't I type anything? Okay. That sucks. Or should I prep this locally? Yeah, we can also debug it. But I didn't do that. Oh, what the hell is happening to this thing? There we go. Okay, it doesn't matter. We're just going to do it theoretically anyways. So now I have add to do, and then what's interesting though is that we now, and this is the thing I really want to explore, because we, the thing that happens with immutability is that you have to make your objects clean. You can't co-locate logic with objects, which is a very, very natural thing to do in JavaScript. So the to do here, I intuitively went to just doing title and completed, but there's nothing wrong in this world to say toggle completed, for example. And we'll add toggle completed. And then we're just going to use this completed equals not this dot completed. Or you know what we're going to do? We're going to say create to do, and we're going to give it a new, what was the title? App.new to do title. Create to do. And that's going to take a title of a string. And then we're going to create a reactive create to do. And then title like this. Oh, sorry. And then we're going to use. Now we're going to return that to do so that we can say to do dot completed equals not to do completed. And we can continue using this pattern of async functions. So doing this, I would be able to like say like input type checkbox checked. Is it checked? To do dot completed on change like to do toggle completed. Like I can even do to do toggle completed. And then we would of course have Kind of sucks, that bug. I'm gonna fix that. But anyways, I'm just exploring. And again, you might argue that like you can't do that on the to-do, right? Like you have to dispatch an action into the system and you have to like handle it there. Like it should be like an app toggle to do completed, passing in a reference to it, and then it updates internally. No, it doesn't have to be that. Like that thing is tied to that item, right? It doesn't matter. This is the thing about immutability. You have to make the change from the top. But with observation, you can just change the value and it will be reacted to in the rest of the system. And again, you can argue like, no, I want to control how that value changes. So you don't know, because now a value can like implicitly change from a component. But that's fine. Like, why can't you do that? Like, maybe you are at a level of complexity where you shouldn't do that. But then that should be something the team agrees on, right? I'm making a silly little to-do app here. Of course I can do that. It's not gonna break the application. Anyways, so I find this really interesting and very freeing because it means I stop having all these generic reference-based actions. I can just put the logic with the thing, and I can do whatever I want here. I can like create and instantiate and use whatever I want inside this thing. Cool. What was the next thing? I guess like remove to do. And again, yeah, this is interesting. So now we want to remove a to do, right? So what we can do is that we can actually say remove this to do. But to be able to remove it, we need to give create to do the ability to do so, because we're not removing it on. So there's two ways you can approach it. You could either have add to do and remove to do, where you pass in the to do you want to remove. We can try that. Oh shit, we can't really run it. That's sad. But we can write it at least. So you can do remove to do. You pass in the actual to do you want to remove, and then you say this dot splice. Sorry, this. Oh, again, app.todos.splice. That will be app.todos index of to do, and we want to remove one. Oh, by the way, I want to do this, and to do is to do. Oh yeah. I think this is the thing that, well, maybe. Like, since you also have the functionality on the type, you're more like going back whenever you implement something new, you're kind of going back and updating the type. Why are you complaining? Oh, sorry. And then, so this is one way of doing it, right? But we could also allow, so we could have like an on remove here. So that would be, yeah, on remove. Where we said, again, we have remove here. Remove, and then we would actually just call on remove. And here we could, yeah, you have to watch from the beginning here. Like this is not, This is not like intended to be published, but it's intended for educational purposes. So what I think would be maybe better, no, maybe not. It's very interesting. Maybe you could just pass the app here. Instead, and that would be state. And then you would actually do app, new to do title. And on remove here, we would actually put this, we would do this instead. So this is very interesting that we can choose to, have like a factory for creating a to-do, and within that to-do you have everything that's related to a to-do, like toggle completed, removing it, and everything, as opposed to needing to have like this flat like reference-based thing. I'm not saying that's bad. You might as well have like add to-do and remove to-do, but it's also interesting that you can just put it directly on the item. Again, it's like it's patterns. That's the thing. But yeah, I would prefer, in this case, I would actually prefer having I would prefer having this one because it's the the thing you're primarily applying to here is actually on the app itself. So yeah, maybe we should call this app instead of state. Cool. And then we have things like, okay, maybe we should look at filter. So filter would be all, what is it? Remaining? What is it? Oh, all active and completed. So we can say the filter is all. And then the question is, we want to only show the to-dos that's part of the current filter. And as I was arguing about is like, you don't need derived or computed. You have get current or filtered to-dos. And then you can just say if app.filter, oh, look at that. Why are you complaining? Oh, interesting. Oh, are we getting in? Oh, sorry. I keep forgetting. Filtered to-dos would be filtered to-dos. Why is it complaining? Oh, yeah. I think this is an issue of... yeah, this is interesting. Because I have experience with like doing a self-reference like this. Yeah, this is interesting. That TypeScript isn't able to do that. Yeah, it's very interesting. So, because what I was thinking about is like, you can create a type like this, but you can also like apply the type as like all or whatever. Like you can apply the type there because it can infer most of it, right? But I'm not sure what my preference is, because then you would also, with the functions, you just put the typing there. But again, it's very nice to have a clean object where you don't need those typing. But that's interesting. Like it wasn't able to use, like we're gonna test something. So what if I do this? Yeah. Oh, wait, it's still not able to do it. Why does it say that? Yeah, so I'm about to turn off the stream. I encourage you to watch it from the beginning. It's a big rant. It's meant for educational purposes, for now at least. So yeah, the best thing would be to watch the stream from the beginning. But in very short terms, I'm very upset about where we've gotten in terms of state management compared to what it was like 10 years ago. It was much simpler to do state management 10 years ago. And I argue it's because of all the abstractions and primitives we've been throwing at this that we need to get back to the core, and the core is just using the language. So I built a thing that has a single primitive called reactive, and from there exploring using the actual language to handle like complex state management. But yeah, at the moment I'm very curious about this. Yeah, it's interesting. Maybe that's a limitation of getters. I'm gonna ask, you know what? Let's take this and ask Chat GPT. Why I have this code. Hi, Henry. Yeah, it's I think it's like it's one of those things. Like I've had a couple of moments where I feel like, okay, I have some good points for education and reflection, and it's this one. I feel like this is worthwhile listening to, even if you disagree with everything. It's like it's useful to discuss it. Like everyone should challenge status quo. And then it was the, what was it called? React States video I made. That was also a good one. It was just, it had the same kind of educational purpose. Like, and it was beyond kind of, yeah, whatever. Anyways, I have this called, why does my getter require, and we're gonna ask the good one here. Why does my filtered to-dos getter need to explicitly type the return type? Even if I use this as reference, the to-do in the filter callback is enabled to resolve. Reasoning. It's considering view. Yeah, it doesn't matter. Oh, it's the reactive thing, I guess. It doesn't matter. Yeah, because that's also interesting. Like Vue actually has primitive called reactive, but it also has a ton of other primitives. When you write your reactive object type, it ends up having trouble inferring the return type of your getter. There are a couple of interrelated reasons. Your getter accesses the object it belongs to either via app or via this. Since the object is defined in one go, it's being wrapped by, there's a circular reference. Typers can't look inside the getter and automatically determine that it will always return a to-do or whatever type your to-dos have. because the types are intertwined with the definition of app itself. And if you change it, this is not infer from the type parameter you pass to reactive. Yeah, explicitly annotate the return type. I mean, that's an interesting fact. Yeah. Okay, nice to know. Anyways, so now we have filtered to-dos. And again, like if we were working with it's the dent. Oh, it's not me, it's our son. He actually has his first dentist appointment. Interesting. Let's see. What were we doing? Yeah, we're talking about the to-do. So like there's no reason to optimize these filtered to-dos, right? The only time well, in the current app, everything's in the same component. But what I would do here is I would, well, maybe we can do that. So this would be to-dos. And then I would have function to-dos. And then for each to-do, I would do to-do, key index, and pass the to-do, function to-do. And this is what I talked about optimizations. Like optimizations now isn't about these primitives. It's just about scoping components. So yeah, we don't need the index here. It's about scoping components. So by just doing this, I've optimized it. So now the only time the app reconciles, like just doing this, only time the app reconciles is when I actually change the new to-do title. This one will not reconcile. It doesn't matter if I'm using state in here or not, it just won't reconcile. Like that's part of the plugin. And then when the to-dos list actually changes, we push or whatever, do something to it, or replace one of the items here, this will reconcile. And then the only time this to-do will reconcile if we actually flip the completed flag, or for some reason the title would change. So it just does what you expect it to do. What other fun functionality do we have? I guess there's nothing else. Well, it's the editing of a to-do. That's an interesting one. So yeah, that's interesting. So, and I wanted to actually explore that. So what if you had edit here? So you just said edit. Now the thing is, you have to know if yeah, and what's also really interesting is like, what does it mean to be like, now I'm using this as an example, but it's like going into the gist of it. Like, what does it mean to edit a to-do? Like, it changes its state, right? So what we could do, and can you toggle completed while you're editing, for example? Like, this is a little bit intense, but because I think the to-do MVC only allows you to edit one. Yeah, it only allows you to edit one to-do at a time. But that might not be the case. Like you could edit two at a time, for example. I don't know. So if you, okay, so let's just talk through that because I have to stop the stream. So in this case, I would just do edit to do title string, right? And if you had that string active, oh well. Yeah, so you would have to like put something like edit to do title, and then you would have to like reference which one are you editing, and then like move the title and stuff like that. But what you could also do is you could put edit on this one. But not only that, you could actually say, okay, I'm just going to duplicate a little bit here just to make a point. So you could have mode or state or whatever, mode, view, edit. So this will be mode view. And this is where you can toggle completed and you can edit. And then you have mode edit. And in this case, you can cancel edit, but you can toggle completed, for example. And we don't even show completed. Well, I guess we still want to have that data. And then I guess you would do a new title, right? So you would still keep. So that's what I would do here. Like to like go even further, I would have like base to do would be title completed. That's always there. So you have base to do, and then you have two different modes on the to do. And that, again, like I'm not doing this to like be fancy. I'm just showing an example of how something that's more complex could get value from having these explicit states. So let's remove this and this. So now we're basically saying we have this to do of title and completed, but based on its mode, if it's a view mode or an edit mode, we have different functionality for it. So when we create a to do, why doesn't it? Oh, yeah, don't actually type it anywhere. We would have mode would be view, and then edit. So this is where, yeah, exactly. This is a state machine. So here I would view. So let's see. I would do view. And then I would do edit. And then I would move this stuff in here. So this would be a to do. This would be a to do. Maybe I can just, no, I think I want to have it in there. So the first version we return is view. Oh, interesting. Yeah, I guess we need to do this. So this is the view state expressed like this. And then we have the edit state expressed like this. And then we put edit. And then we have no toggle completed anymore. And we have cancel edit. And then cancel edit. Oh, yeah. Maybe this won't work that great when it's the list. Well, anyways, let's just complete it. And then we'll see. The thing we need to have when we do a state machine, like we have to, because when you have a state machine, it's kind of immutable in the sense that you replace the whole object every time. You don't change a single value, you change the whole object and you give it a new mode, right? And to do that, you would have to you would have to replace the object. Yeah, this is really interesting. This is the thing I feel like JavaScript is kind of missing. Well, not missing, but you can't replace an object from an object, which makes sense, really. Because what we would have to do here to kind of finish it is that we would have to allow it to do a transition. So the new transition would be to do. It doesn't have any. And what you would say is transition into edit. Would this actually work? Transition into view. Oh, am I missing something? Oh, new title. New title. Would this actually work? Oh, what happened there? Did I assume something? What happened? Look at this. It's zoomed. Oh. Oh, I have no idea what happened. Because now we're creating this view. And then if I apply it, what I'm reflecting on is like the references here. Because initially we have, well, it's immutable, so it shouldn't be any issue. What I'm wondering is like, if I have title here. Okay, so let's imagine I go and edit. I do, I actually apply edit. We didn't add that, apply edit. Again, just to emphasize, I wouldn't actually do this in a to-do MVC. I'm just exploring something. So here I would really, yeah, it's interesting. It's almost like, yeah. Yeah, how would I do this? So if I change the new title here, what I really wanted to do is transition back to view with that new title, which means that I will kind of have title here as well. Which means I would bring in the title here, which is a little bit to do the title, and here it will be to do the new title. Oh, interesting. Oh, doesn't it? Oh, that's another interesting thing. Ooh, the typing here. It should really be interesting. Satisfies to do. That is interesting. Because that's another thing. Like we have a union here, but when we say to do, we say that this can be any of them. But we are actually saying it can be one explicit. So that's what satisfies does. Oh, interesting. Oh, for frick's sake. Oh, yeah, this is a type hell. Yeah, no, I need to reflect a lot more on this one. Unions are a bitch. Yeah, there are two challenges with this. One challenge is like conceptually, what's appealing is that you can actually have exposed the actual functionality of each state. That's great. The challenge is that if you want to actually move between states, you can't do that within this factory because this factory returns just the object. It doesn't know where that object goes, right? So it needs to pass in a function that actually puts that transitioned object in its place. But that's not really a challenge. That's like part of the pattern. But this typing stuff, that caught me off guard. Because if I did this here, oh, that doesn't help either. That's very interesting. So what I wonder is, oh, wow. This doesn't even, oh, sorry. That's not the problem. Come on. Yeah. Wow, that's fascinating. Oh, did I say, no, I said Boolean. Yeah. That is very interesting. But now I can like put foo bar here, right? Yeah, now I can put anything here. And if I do to do here, I can put foo bar here, right? But now this just becomes a to do. It doesn't become this specific view version of to do. Yeah. But this is like totally unrelated to this. It's just how unions work. That is interesting. Anyways, I have to go. I have a meeting. So, but thanks for following along. And I'm going to play more with this. And happy to get any feedback on the repo or wherever. But yeah, this wasn't really the interesting part. It was everything else. Cool. Bye for now.